normality, which one gets reported in a paper? Well, in the methods section, you're supposed to say. But typically it's the parameter estimate one, because you make a table of the results from the logistic regression. Since we did so well, it's going to be boring to go on to methods that might do better. So I'm going to make it worse for us by, first of all, I'm interested in zinc. If I look at zinc, why is zinc such a good predictor? Nothing like going back to the old t-test to see what's going on. There you go. Ah, zinc's a good predictor because the Kentucky ones all have small amount of zinc, mostly, not completely, but mostly, and the US ones are all up here. So I can classify reasonably well with just zinc, especially what? If you're below 40, then you're guaranteed to be Kentucky. Is that a good rule? Well, based on that data, it is. How would that do overall? Well, it's putting a lot of emphasis on zinc, right? But if we have a nice way to test quickly for zinc in our samples, we may have a test that works really well. On the other hand, if you're testing for zinc, maybe you want to test for a few other things as well. Why do they do a whole bunch of medical tests? If they take your blood and they send it to the lab, they do 27 tests, or they do 54 tests, or they do 118 tests. Well, it's because they have the sample anyway. It's not much harder typically to do a bunch of tests than one test, especially when it's done by a machine. So if I want to make it harder, I should not include zinc. And so what if I do these three instead? Fit model, make it a little harder. Interesting. Now both U and TI are important. Huh. You may not be interested, but I'm interested. Why am I interested? Because we had the same sort of result here. From the parameter estimates, I get two small p-values. Down here, oh, I still get two small p-values. Darn, I thought that was the, yeah. They're still similar, like they're supposed to be. Okay. But I got two of them. My confusion matrix, which I think it's funny that it's called a confusion matrix. It's how confused is logistic regression. Well, so now we got it down to a borderline situation, and we got two important variables. So the fact that we got two wrong, I don't know if this version of JMP can't do the leave one out cross validation. That would be interesting to see how it does. If you have a Mac, then you have access to JMP Pro, and JMP Pro does a bunch of leave one out things that's useful sometimes. Okay. Let me shrink that because we're going to come back to it. So now we have a case where we did okay. But we got some wrong, and now we can go down especially, well, let's see what happens if we do principal components, because you're always supposed to do principal components. Even though principal components is not intended to discriminate between groups, if you don't do it, the reviewers will ask for it. It's like, well, why didn't you do principal components? You can say, you can make a mathematical argument. It's not necessary. It's not appropriate. Well, you're still going to get stuck doing it because it might make a cool plot. Is that a logical reason for using a method? Yeah, maybe. Analyze principal components. Remember, there's no response. It's just making a linear combination of the three variables that might have good properties. It's not going to have good properties. One of the principal components is completely the v variable, and the other one is a combination of those two. I wonder if the u and ti are probably maybe highly correlated. Don't know. I might want to know that. If I do my color thing, which I haven't done yet, then color marked by column, not that one. US is blue. There's a plot that does not belong in your paper. It's doing nothing. It doesn't help. It only confuses. The correct sentence for your paper is principal component analysis failed to discriminate between the groups. If I only have two groups. When I have four groups, remember when we looked at this before, it is going to differentiate the four groups, in which case it becomes potentially a useful plot for your paper. But there's no, unless you're trying to point out that particular point's an outlier. Remember, PCA is really good at finding outliers in your data. But if you're trying to point out something interesting about that particular point, then PCA found it. Multivariate methods, discriminant analysis. There's my three variables and my origin variable. And now I'm running the optimal method for multivariate normal data, and my little picture, it says they're separated reasonably well. There's a couple of blue guys over here. That's not so good. Over here in the with the red ones, any red ones that are, so there's the two problem ones. Why am I getting the that red one? I guess those two red ones there are being annoying. Do I have some evidence? So I might want to, let's see how I did. Anyway. Why do I have all the data back in?
It's only predicting U.S.
Yeah, I know, but Excluded and hidden, hidden may make it go away. Multivariate discriminant, recall. Picture should look exactly the same, it does. It's still got them in there. Huh. Go away. How do we do it at discriminating? I did the same, right? No better, no worse. Probably got the same two wrong. Not necessarily, but probably got the same two wrong in each category.
Just out of curiosity, what happens if you take the logs of your X's now?
They right.
Since LDA assumes that they're normal.
Right, and so let's see. We would want to make them more normal, right? And so, I could talk about Box-Cox transformations. You can actually do the transformation that makes the variable the most like a normal distribution. Yes, this is a digression, but something that you may experience. So, this is called the Box-Cox power transformation. Who uses this? The engineers. Have I seen? I see it in some